Hey, hello everyone. I don't see you, by the way, so you can do whatever you want. I just see light. Okay. Hey, people still coming in. Okay. Before we start, I have a question, and it's going to be hard to see, but let's try. Who is not using microservices? Your hands up. All right, a few people. Okay, the rest of you, the ones who didn't raise your hand, you're not going to like this. The guys that rose their hands, do you know Linux? I use Linux as an operating system. You know what this means? That is a command that shows you the pit of a process in Linux. And that is the result that you get when you run this command. Now, that is a fairly simple command, right? Or is it? If you think about it, what it does is it has to go search the table of all the processes, find the processes that match a given expression, then figure out what their pits are, and then display this to you. Essentially, it's doing this. Right? Have you seen that in Linux before? So if you actually execute this, you're going to get pretty much the exact same result. Okay? Now, what's the difference? The difference is you have monolith versus microservices. So if you've done this below, you're doing microservices, go tweet about it. All right. Do you know what microservices are? You do? Anyone knows? I don't see any hand. That's good, because I don't know either. And I kind of have the feeling no one knows. But these two guys have taken the effort to actually provide what they call a microservices characteristics. So this is by no means a definition. It basically says the people that claim to do microservices typically do those things. And you will see things like componentization, smart endpoints and dumb pipes, and yeah, you can go ahead and read it. It's actually a very nice article. But if you look into that thing closely, you will realize that about half of those are not actually related to any software technology per se, but rather they are operational. Rather, they are related to a company culture, to a way you operate, to a way you work, than to how you actually build software, right? So if that is the case, why you should you consider microservices? So the most common answer I hear over and over again is reducing complexity. And here, typically, people by complexity mean a lot of different things. But in general, monoliths are like, no, it's big, it's huge and complex. And we do it microservices. It's going to be nice and clean and tidy. OK, so here we go. We built a small or big, whatever set of tiny little things. Those are our microservices. And then we need to deploy them somewhere. Something needs to, serve them. So then we use things like Undertow, Jetty, or whatever, Vertex, or Drop Wizard. Then we're probably going to package them in something like Docker, or vServer, or whatever that is, or VMware, or Xen. And then you go cloud, obviously, because nowadays everyone goes cloud. And then you have to kind of orchestrate anyway those things. So here where things like Kubernetes come to play, or OpenShift, or whatever is the favorite thing. Then you realize that although those are separate things, they actually kind of play nice together. So you have things like log aggregation, monitoring, and so forth. So a bunch of other tools come into the picture. And here you go. You've reduced the complexity of your application. It's so much better now. OK. Those two guys that I showed you earlier, they also write this thing, and I think those are the two most important sentences there, is by doing this, what you're essentially doing is shifting complexity from one place to another. And the worst part is you're shifting it to a place which is much harder to control. So really, really, really think about it. But so microservices are cool. And so what's so cool about them? Take a second to read those things. I don't want to read them for you. But I did a search on the internet, figure out those things. And do you think those apply for microservices approach? Like, that is why they're so cool? You agree with that in general? Yes? No? Please? Yes? Good. Because those are quote about EJB from 1999. That's how new microservices are. And speaking of EJBs, and back in the old days, there is a report from Gartner, which is not available online anymore, but thanks to Wayback Machine, you can actually find it. That's a report from back in 2001, I believe, which says that companies have overspent about $1 million on technologies they don't actually need. They were just made to purchase those technologies by software vendors who convinced them that that's the technology they need in order to operate. Now, that's not the case today, obviously, right? The fact that we have a bunch of big players out there in a cloud infrastructure setting micro containers all over, it's just a coincidence. Never mind. Anyway, so let's just say there are a few big companies doing microservices, so let's look at those. So obviously, there is a Netflix. If there is a microservices talk without mentioning Netflix, please show me, because I haven't seen one. But obviously, guys are doing a great job. And there are also a bunch of other companies doing a great job on microservices. What do you think they have in common? Like looking at those lists and all the other guys that you know that are doing microservices. They do microservices for their own needs. And I guess that's the case for a lot of people in this room. You probably are in a company where you build services to kind of deliver capability, to deliver functionality to end customers. So you're the one who is building it, who is deploying it, and so forth. So if that is the case for you, then in fact, microservices may be a good solution. Because the question is, can you build a DevOps culture in your company? Can you hire the right people with the right mindset to do it the right way? Because as we saw in the beginning, the bullet points, half of it was operations. Half of it was how the company operates. Okay, but if you are in a business like I am, a company called LifeRay, which delivers a portal solution that other companies will take and build something with it, you can't really do this. You cannot go to a customer and tell them, listen, we have a great solution for you. It's basically an ideal option for your business problems, but in order for it to work, you need to remodel your company. You need to change the way you operate. You need to fire these guys, hire these guys. You can't do things like that, right? So if you are in that part of the circle, like microservices may actually not be a good thing for you. Another thing to consider is, if you look at the names, those are companies that have a very good teams, very high-quality developers. It's not obvious that if they can do it, you also can do it. I mean, I know you're the greatest in the world, but just for a second, really compare your capabilities to whatever their capabilities are. So, should you do microservices? Well, the question is, are you mentally, organizational-wise, and in all those terms, anywhere close to those guys? If your organization looks much like this, if you are able to change your culture to accept this, then probably yes, then probably it's a good solution for you, apart from a technical challenge, right? If not, I would say don't even try it. And those guys will tell you the exact same thing. You should not start with a microservices. You should start with an application. Call it a monolith, another buzzword. That is modular. And then, if the time comes, then you realize that the microservices are a better approach. You can easily switch to that. But don't try to go into the microservices as a start. Why? Because microservices does not cure complexity. In fact, nothing does. The complexity of your application comes from the domain model. If you are building ERP system, if you are building online transactions, whatever that is, that domain contains the complexity. And that complexity is not going to go away, no matter how many small pieces you're going to put into that. That complexity comes from your model, from your domain, from your knowledge, and from how much you actually want to model, because you don't have to kind of to model the whole thing. So there is no cure for complexity, but there is a treatment. And the difference is obvious. Cure is when you kind of apply something and the condition disappears. And in some cases, it's just never going to disappear. You just have to treat it constantly. And that is the case with complexity. You have to have a treatment for complexity because it ain't going to go away. And that is modularity. You need to make sure that your architecture is modular. Not necessarily microservices, but modular. In fact, there is a guy called Uncle Bob, maybe heard of him, who says there is no such thing as microservices architecture. Microservices is a deployment detail. And I highly agree with that. That is how your architecture should look like. Whether you deploy it as a microservices or not shouldn't matter if your application is built the right way. Now, a lot of you are saying, yeah, right. But in my case, this is not going to work because our application is too complex, or because we use this, or whatever. So, I want to try to show you that it is in fact possible. And what I'm going to do is I'm going to try to modularize, right here in front of you, an application that is delivered, not this way, by Oracle. And it's called, that's from the Oracle's reference implementation of Java EE 6, or you can take any Java EE. It's called Duke's Forest. That's how they diagram it, like what it is. It's highly EJB, uses Glassfish. In fact, you can't even compile the thing without Glassfish running. So it's like the perfect thing that you would say it's a monolith. Although it's composed of modules, but we'll look into those in a second. And those are the relationships. So I basically copied the code into my own repo. The repo is online, so the next few minutes I'll be just checking out Git commits, showing you a little bit of differences, just so that you get the idea. I don't expect you're not supposed to understand the code as it is of now. You can go ahead and look at it in details later if you want to. Try to catch the general idea of what we are doing and not exactly of the details. Okay, let's try to see that. So first thing I'm going to do, can you see, or should I increase the font? I assume that is okay then. And no one says nothing, so here you need to do install actually. So this builds something that is, there's no my changes at all. This is just whatever comes out of the box. And I already have Glassfish running. So let's go to here. This is how it looks like. You have an application, you have products, you can actually log in as administrator and have a bunch of other things. I'm not going to go into detail. Unfortunately, they don't have any unit tests, so I'm just going to use the web UI to show that that thing works. Now, as you see, they have products, which means they have something like, say, product catalog. And the scenario is, there is another developer now coming and say, you know, guys, we really need to build this other project. We need a product catalog for it. And we heard that you already have one in your application, so we just want to take it from there. Can we do that? So sure, go ahead. There's the source code. So then what you're going to do, I don't know what you're going to do, but what I would typically do in this case is I'm just going to look into the source code using a static dependency analyzer like JDepend, for example, and generate a report like this, and get scared. Where the hell is the catalog? It's nowhere there. I mean, I can see all kind of EJB relationship thing, but nothing tells me about the catalog. OK, let's try to fix that thing for a while. So, few things I'm going to do in the beginning. Well, in fact, if you look into the code, you will see that they have a module called entities, but that is not actually a real entity. Well, it is actually a real entity. It's just tightly coupled to JPA annotations and so forth. So let's try to extract the domain model, rename all those things, and then move that into a separate module. So basically, this is the difference in this 4 commits that you saw. So we now have this Duke's domain model as a separate project. We extracted just some beans. And then we obviously need to change the references in the other implementations. And in our entities, we actually tell that those are entities. It's just basic. There is no change in the logic. This is pure refactoring, moving code from one place to another. Okay, we just kind of modularize the thing. Okay, so the next thing we're going to do is we're going to create a use cases for the modules for the use cases that we have. Now, how many use cases we have, that depends, of course, of how we define things. But basically, I've defined something called use cases catalog, use cases for e-commerce, and use cases for identity. And what we have here is an abstraction that says, this is the use case. Let's say, for example, product manager. This is an abstraction that says, we have those use cases. Right? We need to be able to get a catalog, product, save a product, whatever. And you have more use cases, you put them in here. And you also have something like wiring things. For example, here you wire persistence. You say, this is going to be something that's going to persist in some way. I don't really care how, where, what. I just want to have an extension point where I hook something and it is capable of persisting an object. So that's essentially what we're doing here. Again, it's no code change apart from a few interfaces. It's just refactoring. OK, so then we move the implementation of all this persistence and other crazy things out of the EJB layer into our own thing. So we, for example, are going to create a module that is going to be called JPA persistence. And all this crazy logic that they have about how to store things using JPA is going to live in that particular module. No other module outside of that folder should ever know anything about JPA. Right? So it's just moving the code there. Basically, that's what it does. What is the next thing to do? So now we need to change the EJB to actually, the EJB layer this time is going to be only wiring things. So we have the domain, we have the persistence somewhere, we have a few other modules. The EJB layer will be just wiring those together. And the web layer on top of it, it's just going to be using the EJB layer to get any data. So, oops. What happened? I hope. Here we go. So again, it's a lot of refactoring, but not really any code changes. I'm just going to show you how this wiring works. For example, let's take a product bean, and this is how it used to be. So you see, you have all the JPA stuff in it. It's just mix and match. In this particular case, we are just using annotations to wire things. So we'll say the persistence is going to be implemented by this entity manager, whatever that is. It's just pure wiring. There's no logic in the EJB layer at all. OK, let's do one more thing. That is, again, pure maintenance, just changing this into modules and reorganizing Java packages. So we just basically get these guys from here and put them into a Maven module called GTE apps as cosmetics, nothing, no code changes. OK. Now, let's compile the thing. I need to use install here. All right, and before I go forward, let's just make sure it still works once it compiles. Here we go. This was here. So let's reload that. Yep, it still works. That's good. So it didn't break anything. However, let's see how this looks like now in terms of structure. It looks like this. So we now clearly have use cases. We now have a persistence layer using those use cases and saving data somewhere. And we have the wiring layers that are just wiring. You see the arrows going between the wiring to the persistence and to the use cases. So you know that this is purely wiring things together. And then you also have the web layer on top of that thing. This a good foundation. So now back to our guy who wants to only use a catalog. What he can do? Well, he can just grab the use case catalog and use it in whichever way he wants, right? Let's see what he wants to do. Well, he wants to build a microservice, obviously. So how he's going to do that? He's going to use a very great technology called Spring Boot. Anyone who is not familiar with Spring Boot? OK, good. So in Spring Boot, you can do quite a few interesting things. One is you just create an app and puts your annotations in there. And then you create your REST services, like, for example, Product Manager here is a REST service. And here we just wire it with a persistence. And here, for simplicity, we are not going to use a real persistence, but just in memory persistence, which is implemented in somewhere here, product storage. So this is stupid, dumb thinking, saving things in memory. So let's build this. And oops, no. Okay. Okay. Catalog microservices, target, and here I can do Java, jar. And here we go. That's a microservice package as the executable jar file running on the exact same code. So let's see how that works. I also use a JSON doc thing to demonstrate that. So we have this thing called product. We have this thing category. That's pretty much all we implemented. So you can get a post and actually create actually you can see that there are no products. Like if you submit, there's nothing. You can create a product or whatever. And then you list the products, and then you have your product. So we just created a REST service from the exact same code base that minutes ago we were using into an EJB monolith, right? Just by restructuring the application. Now, this was the buzzword, microservices, so everyone's happy. Now, here comes the part that you're going to hate me about. Is the scary thing. It's called OSGI. Anyone who does not know what OSGI is? OK, good. So let's say we want to make those things an OSGI bundles. How complicated that is? Well, it's as if you're using Maven, it's just adding this to your POM. That's basically all the complexity. And it's going to generate a bundle. A bundle is just a jar file that has a specific manifest. OK, so what else? Since we are going to use OSGI, we're going to have the OSGI service to wire things together. And we're also going to have a shell commands. I'm going to tell you what shell commands are in a second, for those of you who don't know. But let's look at the service first. So it's the same concept. We have, like in Spring Boot, we have something called product service. We tell OSGI it's a component, and it's a service, an OSGI service. And we tell it references something that is product persistence, something that is capable of persisting products. We don't really care what that is. For our demo purposes, we did implement the exact same in-memory storage here. But basically, that is for the catalog service. Now, we also create something called command, because OSGI comes with a nice shell where you can create commands. And you can just say that you want to create commands, and then they map to particular methods, and then you use them from a command line. And you'll see that in action in a second. OK. And OK, we also going to create an OSGI REST endpoint, so we can use this from the outside world. So the REST is Jigsaw, standard annotation, nothing fancy. If you know how to build Jigsaw, you know that this is pretty standard. And also, you need a bunch of jar files. Now, you may think that this is kind of quite a lot of complexity, quite a lot of jar files out there. Wait a second, I'll show you what's inside the Spring Boot jar. OK. So that's pretty much everything you need. So let's build the whole thing again and see how the architecture changes. OK. Let's look into the JDepend report again. So you see that we are now heavily abusing this use case catalog thing. Now we not only have it used here by the Glassfish thing, but we also use it from the Spring Boot thing, and we also have OSGI using it. So basically, that's a third way of building an application out of the exact same code base, right? That is really something that I like. OK, so let's see how that works. It's here. Come on. That is going to be this one. Of course, you need to start a server first, otherwise it doesn't work. So let me start, not this one. So let's go to Felix. OK. So this is the console that I was talking about. You can do things like list bundles, and you'll see that we have all these jars that we installed and so forth. And somewhere down here is our catalog management use cases. Here are the commands. This is the REST endpoint, and so forth. You can stop and store things all over the place. Doesn't really matter. Now, let's see how that works here. So we have, this time we just implemented the product thing, and we only list things. We only have get methods. So there's no way to add a product. Oh, wait, there is, actually, because we created a command. And command was called product and has add option. So we can say it's a test product. Sorry. Obviously, I had to do it wrong. And it costs 223 something. You also have a product list command, so you can also list them here. But more importantly, now you have it here. So we now have two different interfaces for the exact same functionality. One is a command line, and the other one is a web service. And that is all running inside the OSGI container. Now, we have two things running here. Spring Boot, still running, I hope. Let's see. All right. And OSGI. Let me stop the glassfish, because we don't need that anymore. In the meanwhile, I'm going to start LiveRay. OK. And let's use something like bin. OK, you know this tool, JVisual VM? I hope you do. So here is my Spring Boot process somewhere. That's the one. And that is my OSGI container. And that is to a few of those guys who keep telling me that OSGI is so huge and complex and microservices are so tiny and cool. That's how it looks in runtime. Spring microservices, that's Undertow underneath, by the way. That's not Tomcat or Jetty. That's Undertow, which, according to a lot of people, is the most efficient thing ever. So it uses about 700 megabytes of RAM. Currently uses about 100. And it loads over 5,000 classes. And it does nothing more but serves that one service that we created. It does nothing else, right? Now, OSGI Felix runs at about 300 megabytes of RAM, and currently uses about 50. Loads about 3,500 classes. That's how they differ at runtime. So when you talk about tiny little microservices, that is only true for the code that you write. But once you deploy it, you have to keep in mind there is a bunch of code you never see that is all the time, every time, surrounding your microservices, right? Keep in mind that this is how it works. OK, so I show you, I did one scary word. No one got scared, so I'm going to actually use another one. That's going to be portlets. Who knows what a portlet is? All right, not a lot of people. Well, portals and portlets, especially if you go in a DevOps environment like this, they're no-go. But hopefully, I'll show you that they're not that scary after all. Let's try to see what is it to build a portlet for a solution like LiveRay. Well, LiveRay 7, which is going to be released later this year, is already fully OSGI-based. So to create a portlet, all you need to do is basically create an OSGI service. So you just create a class, you provide the right annotation, you reference any other OSGI service that you want to use, and that's pretty much it. Then you have a bunch of GSP files to provide the view, right? So that's pretty much it. So let's build it. Sorry, you can't do install anymore because Glassfish is not running. So now you need to do package. They really have a nice build system. Anyway, so this is going to dynamically build and deploy the portlet inside the LiveRay. So let me log in here. All right. Let me create a page for that portlet. Sorry, page. And let's put it should be Duke's catalog. Here we go, deployed already. So because we store things in memory, of course, there is nothing to display. But remember, we have these cool OSGI console commands, except we don't have any console for LiveRay. How do we get there? Well, we get there by doing this. Oops. Yeah, and you need to spell it right. And you've just telnet it directly into the live race shell. So now you have a shell that is the same as the Felix one that you see earlier, except that here are 123 bundles already installed. But you still have the same options. So I can say product add, I'll keep it simple this time. And if I look into my catalog now, here is my product. I already have it in a portal. That's how complicated that is. And I know what you're thinking. Yeah, you're showing me a solution that is a monolith of itself, and you just covered. But yeah, if you want to run this into a different servers or whatever, so what is what we do then? Well, there is a thing in OSGI that is called DOSGI, which stands for Distributed OSGI. And let me show you how that works. That is also a very complicated thing to do, which is the right one. It's here. OK, so those are 3 comments. One of them is actually a workaround around Jackson, who is not capable of dealing with lists of generics. So if you just have a list of an object, Jackson is not capable of deserializing those. So one is the workaround. But the only thing that in these 3 comments that makes your service remote are these 5 things. 4 jar files that provides you the DOSGI implementation, the topology, and the discovery. And you could use different implementation, depends on what topology and what discovery is there, or you want to have. And you need to find your service, which is a standard OSGI service, and tell OSGI that want to export it remotely by providing one property like this. That's basically all you need to do. You just say, I want every implementation of that service, or the implementation I provide, to be a remote. And that's it. So let's build again. Here we go. In the meantime, I'm going to restart Felix, because I didn't install the bundle that automatically redeploys stuff. And I'm not going to start it yet, just to show you why I do this. No, install it's not working. Package it has to be. OK. OK, so, and now let's look inside this thing again. So we redeployed it. Obviously, memory got cleared, so nothing to display. So, but that's OK. Let's see what's going to happen. And I didn't show you something rather important. So wait a second. I hope we see the portlet here. No, it's not here. Here it should be. So one thing that is also that I actually wanted to show you but kind of forgot. Realize how this reference thing in OSGI works. It has 2 parameters here. We say the reference that we want to use is dynamic, and it's optional. What we tell OSGI service layer here is we will work regardless of whether that service is present or not. It can show up and disappear at any time. For us, it's optional. We will deal with it no matter what happens, right? Because in OSGI, things can show up and disappear at any time. And then, in our rendering thing, basically what we say is, if the service is there, display whatever we display, and if it's not there, just display an error page. And that is actually the thing that I want to show you now. OK, so I need to move back in the demo. OK. So we should be at a good place now. Okay, so now the service is there. It's not displaying anything because we don't have any products. But I'm going to go and remove the jar file. I can disable it, but just so that you trust me that I'm not faking it. Liferay portal, OSGI, modules, catalog, service. I'm going to just delete this. And if I reload this, okay, wait, it's, I messed up things. So I need to recompile this again. No, not this one. Because I was going back in the demo to show you the portlet, so I need to recompile this so the files are all in place. Okay. Give it a second. Let me see. Okay. Okay. So here is the result you see now. You see this is the error page. Basically, this tells us, well, you know what? In order for me to display something to you, I need this backend service, but it's not there. So I'm just going to display this to you, say, go get some coffee. In the meantime, we'll fix the problem. So if I restore the jar file, obviously it's going to work. But what I'm going to do instead is I'm just going to start a Felix instance, which is a completely different JVM. You know, in this case, it's on the same machine, but in theory, it could be any other machine. So all I'm going to do now is just start a Felix. Okay. Let's make sure we have all the bundles. We do. And so when I go back here now I have a catalog service again. I can again display some things, just they come from a different place, and that different place is Felix. And if you don't trust me, just make sure this is Felix, it's Felix. So I can say product, add, test. Come on, don't. Okay, and you will see that now I have a product coming from a completely different remote instance, not from Liferay itself. In fact, if you try to do this in Liferay, where we have this telnet thing, if you try to do the same thing in Liferay, well, that's still going to work. The reason is that command is also independent on the service itself. So now I connected to a Liferay instance, and from the shell of that Liferay instance, added a product in a remote instance. Right? And this was all transparent. This was all wired together by the OSGI framework and by the design of the application that I've chosen. Okay. So much for the live demo. So I wish I was. So we started from something like this, where we had like everything in Glassfish. We had these kind of modules because they can like shipping and payment and store kind of separated, but it all was kind of tied together. In fact, you can't even compile it without the Glassfish. And we move the architecture into more like this, where we have the domain model in center. Then we have use cases around it, which provide all the logic and gateways to external stuff. And the external stuff is services, persistence, gateways, whatever that is. And then the final circle is the service layer, is the environment layer, where we have different things. And what we've seen in practice was this. This is how it worked in EJB stuff, in Glassfish. You had the domain model and the use cases in the center, and then you have the EJB controllers, JPA persistence, JSF display, that's what Glassfish used, and J2EE container, which is Glassfish itself. What we did next was we did the Spring Boot application, which is the domain model, the catalog service, in-memory persistence, and Spring Boot. Then we did the OSGI stuff. We just used the exact same thing, just used different thing to actually render it. And finally, we did the exact same thing with Liferay and Portlet. Our domain model and our catalog use case didn't change at all. It was the exact same code base in each and every scenario. Okay, I wish I was able to tell you that I'm so smart that I invented this. But that is not the case. Actually, this is a well-known thing, and it's called clean architecture. And for those of you who are familiar with Uncle Bob and all the other talks about clean architecture, it should be pretty obvious what I was doing. So it's nothing new. This thing has been around for quite some time. And if you care about building modular applications, I really recommend you to go ahead and look into that. The thing is, modularity is an important thing. You need to be able to deal with the complexity of your application by splitting it into modules in the right way. But that not necessarily means you need to jump on the microservices bandwagon. If that is okay for you, if that is okay for your organization, and you've done the search and you know microservices are good for you, then okay, then go ahead and do it. I mean, I'm not against microservices, but don't jump on microservices just because everyone else around is talking about microservices. Think about what are your problems in your architecture that you need to solve, and look for a solution for those problems. Don't simply use a technology because it's great. Now, if you think that is only a theory and it sounds not great, but no one in real life is actually doing it, well, we are doing it at Liferay. Now, we choose OSGI, and when I published those slides on SlideShare, someone commented like, yeah, but I like the deck, but claiming that OSGI is the universal solution for everything is just, I was like, I never did that. I never claimed that OSGI is the to be replacing microservices, right? I'm just saying that it's there and it's capable of doing those things. Those things in the list the bullet points that I was showing you earlier that are related strictly to software development and not to company culture can be addressed by using OSGI. Whether OSGI is good for you or not, that's a different story. You need to kind of consider it for your particular use case. For us, it turns out to be very, very good technology, and to the point that we are shifting. Those are the characteristics I was talking about. So for those that are related to software, it actually makes sense. And so for us, we're shifting a product that is a huge code base. You'll see it has whatever 5 million lines of code, right, into a modules. Now that slide is outdated. That says 80 apps. I think the amount currently it's about 200, and all those are OSGI modules. And one thing that I wanted to also point out is Liferay is a portal, and as a portal has been modular since the day one, because you have the portal and you have portlets that they're deployed, so kind of like modularity is been there always. But up until now, we weren't able to build modules for modules. So modules in themselves couldn't have smaller modules, and those smaller modules couldn't have their own smaller modules and so forth. And what OSGI let us do is do exactly this. We have the service layer of OSGI, and we just register services there, and then one service say, I can operate as long as I have these other services, or I can operate without these other services as long as something else is there. So it's abstract. It's the exact same thing that you do with microservices, except it all happens inside a single JVM. And if we need to move it out of the JVM, we can. We can scale it out as much as we can, but we can run it on this very laptop. And on this very laptop, I can run a unit test that go and randomly deletes bundles and copy bundles and replace bundles and test how this system behaves when bundle is not available anymore, which is essentially what what's called Chaos Monkey of Netflix is doing, except I can do it on my laptop, right? So for us, it turns out to be a very, very good technology. Whether or not it's for you, that's you need to decide. That's it. Thank you. All right, questions. I think we still have like 10 minutes or so.
Does anybody have any question? Okay, so thank you for your presentation.